Good morning, students. Good morning, students. Today, we will start the unit number 1, performance of transmission line for the power system 2. Topic to be covered today. First topic, ABCD parameter by two-port network transmission line. Second, relation between ABCD parameters. First, we start the ABCD parameters of the transmission line. Transmission of power from generating unit to the distribution unit can be done through the transmission line. During transmission, many losses occur in the transmission line, which decrease the efficiency of the line. For improving the proficiency of the transmission, two-port network are used. A network having two inputs and two output terminal is known as a two-port network. A network shown below has four terminals, in which A and B represent the input ports, and whereas C and D represent the output ports. Here, the two-port network figure is given. The A and B represent the input networks, and C and D represent the output networks. A network having two input and two output terminal is known as a two-port network. The voltage and current in the output and input terminal of a two-port network are given by the equation shown below. Vs, which is equal to the AVR plus DIR. Is, which is equal to the CVR plus DIR, where Vs and Is is the sending end voltage and sending end current. VR and IR, the receiving end voltage and receiving end current. ABCD are the constant known as the transmission parameters or chain parameters. These parameters are used for the analysis of the electrical network. It is also used for determining the performance of input, output voltage and current of the transmission line or transmission network. The above equation can be written in a matrix form for easy calculation, shown as Vs VR is a column matrix which is equal to the A, B, C, D. It is a 2 by 2 matrix into VR, IR. It is again column matrix. The matrix ABCD is called the transfer or transmission matrix of the network. ABCD parameters for the open circuit. Here the open circuit means the receiving end is open terminal. So the current flowing through this receiving end, it is equal to 0. Only the receiving end voltage is there. So in open circuit, the output terminals are open and the voltage remains across them, which is EVR. Since the circuit is open at the receiving end, the current IR remains 0. So the equation Vs becomes AVR plus B into 0. So Vs equal to AVR plus 0. So A, the constant A, which is equal to Vs by VR at IR equal to 0. From above equation, we get the value of A parameter, which is the ratio of the sending end voltage, the receiving end voltage. So it is a dimensionless constant because the ratio has the same dimension. The ratio of the voltage by voltage. So it is a dimensionless constant. Similarly, if IR, which is equal to 0, is substituted in the current equation, this is the current equation, Is, which is equal to CVR plus D into 0. So is equal to CVR plus 0. So C constant, which is equal to is by VR at IR equal to 0. We get the value of C parameter, which is the ratio of sending end voltage, sending end current to the receiving end voltage. The unit is Siemens. The ABCD parameter for the short transmission line. Here, the receiving end is short circuited. When the receiving end short circuited, the voltage VR becomes 0, only the current is flowing through this closed circuit. And sending end voltage Vs and sending end current is I. For a short circuit, the voltage remains 0 at the receiving end. So Vs, which is equal to A into 0 plus B into IR. So Vs, which is equal to 0 plus B IR. So value of B constant, which is equal to Vs by IR at the VR equal to 0. If we put VR equal to 0 in the equation, we get the value of B, which is the ratio of the sending end voltage to the receiving end voltage, receiving end current. The unit is ohm. Similarly, if we put B in the current equation, we get Is equal to C into 0 plus D into IR. So Is equal to 0 plus D IR. So constant D, which is equal to Is by IR at VR equal to 0. Receiving end voltage is equal to 0. So we get the value of D, which is the ratio of sending end current to the receiving end current. It is a dimensionless constant because it is the ratio of the same parameter. Next topic is the next point is relation between the ABCD parameter. For determining the relation between the various type of network like passive or bilateral network, reciprocity theorem is applied. The voltage V is applied to the sending end and the receiving end is kept short circuit. So here we can apply the voltage at the sending end and at the receiving end we can short circuit. So the voltage becomes 0. When we short circuit the receiving end terminal, the voltage becomes 0. Since under short circuit the receiving end voltage is 0, the voltage and current equation becomes B equal to D into IR1 and IS1 equal to D into IR. Similarly, the voltage is applied at the receiving end and the input voltage remains 0. Thus, the direction of current in the network changes, which is shown in the diagram. Here, the input side is short circuited and the supply is given to the or voltage is given to the output side. So, when the when the sending end voltage is short circuited, the voltage becomes 0 at these two terminals, only the current is flowing to the input side. The sending end voltage becomes 0, the current flow through the receiving end is given by the equation which is equal to 0, which is equal to A into V minus B into IR. So IR2, it is the receiving end current which is equal to AVR by B, A into V by B. So minus of IS2, which is equal to C into V minus D into IR. So consider the network is passive, that is, it contains only the passive component in the circuit like inductance, resistance, etc. So the current remains same. So Is in sending end voltage, sending end current is equal to the receiving end current. By combining the above equation, we get the Is2 which is equal to IR2. Next, minus of IR1 which is equal to C into V minus D into A into B divided by B. Dividing the above equation by V by B, we get AD minus BC equal to 1. This relation helps in determining the fourth parameter if we know any three parameters. So AD minus BC equal to 1. If we know the three parameters, we can calculate the fourth parameter. Next, for a symmetry network, the input and output terminal may be interchanged without affecting the network behavior. So voltage V, which is equal to B into IR1, and IS1, which is equal to D into IR1. If the network is supplied by the input terminal and the output terminal is short circuited, then impedance becomes ZS1, which is equal to V by I in ISS, which is equal to D by D. And if the supply is from the output terminal and input terminal short circuit, then impedance becomes ZS2, which is equal to V by I R2, which is D by A. In the symmetry network, the impedance remains the same. So ZS1, which is equal to ZS2. So B by D, which is equal to D by A, means A, which is equal to D, means the constant A is equal to constant D. So thank you very much for the today's lecture.